So, hello everyone. Now I'm going to explain the task one of the lab assignment. And here we have to implement the linear regression. And if I show you the code, here is our code for the lab assignment. And we use it avalon.csv. And we have feature columns like length, diameter, height, and age, etc. So, and here the thing goes on, we did normalization, everything is common. And here we define the model um, as sequential model, and we use it different layers with different activation functions as tan and relu. And here I use it loss as a mean squared error, and the optimizer is RMS prompt. And if I compile and so here fit our model for training and testing data, and here I use it approach for 800 and the batch size is 128. So so it is taking a lot of time, so I just plotted the and I'll show you the output. So here is our tensor board graph, and so we calculated for so for optimize we use it two optimizers as Atom and MS prompt, and with different batch sizes and different activation functions and approaches. These are the results we got. And yeah, so and here is our loss graph. And using the evaluation above, we can see that RMS prompt gives the better training loss and compared to Adam optimizer, and also approach and learning rate plays a very significant role in the same. So this is the end of our task one. Um, so here is our task two. In order to implement the logistic regression, here is our code. And I just divided my code into four subparts because we have to we have to change three hyperparameters in order to report the accuracy changes. So for that, here is I use it a sequential model, and I use it optimizer as SGD, and everything is the same. And this is the plot function. So for the first one, I use it optimizer as SGD, and the batch size is 128, class is 10, approach 100. And for the second file, I just change it the optimizer as RMS prompt with the same having the same batch size, classes, approach. And for the third one, I use it the same as GD optimizer again, and I change it to approach 20, classes 10, and the batch size is 50. And here is the same thing, same these parameters with optimizer. It's RMS prompt. So there's just an error. So when I just run this, here are the some code snippets I can show you. And so for the batch size, I just like part one is with batch size the same as GD. I just explained you. Um, so here for the fourth one, I use it optimizer as SGD for 100. And here if you see the conclusion, so the accuracy is 0.92, 93%, 92%. And so from this we can observe that we get slightly more accuracy when approach is 100 and the optimizer is SGD. So yeah, and I'll just run the code and will show you. Um, And so I just executed my code, and here you can see the loss as 0.28 and the accuracy as 92%. And here I just plotted a graph for the approach and the loss. So the graph is like this, and if you want to see the TensorFlow graph, um, So I just took a snapshot because it is taking a lot of time. So yeah, here is the TensorFlow graph for my accuracy in the loss for this one. And